Hello and welcome to the Daylighting in Ladybug Tools series. In this video, we will review how to take prepared geometry and start simulating daylighting using the grid-based point-in-time simulation recipe. So let's get started by first going to Grasshopper. And in Grasshopper, I've already set my geometry. If you're looking for a video on how to do this, you can visit the Ladybug Tools Daylighting Kit book and find videos on how to set your geometry up. In the Honeybee Radiance tab, we're going to drop down, we're going to select the recipe that we want to use to simulate illuminance point in time. So what point in time means is it's a single day and hour that you're going to receive the illuminance values for. So we're going to do a grid-based study. So you have the option to do a view-based study, but in this video we're going to cover the grid-based study. And the first input when you drop down the point in time component is the model, the geometry that you've set up. So because we already have the model with the grid set up for our video today, I'm going to connect the model output to model input. And the next input here is the sky. So we can go to the light sources and we can select the CIE standard sky. That's what's typically used for a point-in-time study. When we switch to annual studies, we would look at the climate-based sky. But for a point-in-time study, we want to start with the CIE standard sky. So we'll take that and drop it in. And as you can see, I'm working backwards. I'm starting with the recipe I want to run, and I am working backwards to find the components I need to make this recipe run successfully. So I'm going to connect the sky input to sky. Then when you see an orange component, that means there's inputs that are missing. So I need to give it a location. So to give a location, we're going to go back to like the Ladybug Tools tab. And when we go to the Ladybug tab in 0 import, there is a import location because we don't need all of the data, we just need the location information. So we'll connect that. And the location component requires an EPW file. So we can go back to import and we can say import EPW. Actually, we're going to do, import EPW. Oops. To import an EPW, we're going to go to the import tab and we are going to click on download weather. So here's where we can take the EPW file. And the last piece we need is a URL or a location on your computer for the weather file that you're using. Since I already have a location copied, I'm just going to connect that here for the purpose of this video. If you need to find a weather file, you can always go to LBEPW map and toggle that to true and download a EPW map from Ladybug Tools. Okay. So we've got the weather file, we're ready to go. The last piece of information that we do need here is a month, day, and hour. And you have the option to choose the type of sky here. So let's start with the month. All of these inputs will be sliders that go from starting point to an ending point. So a month is going to go from 1. If you do 2 decimal places, that will start a slider that gives it a range, so 1 to 12. So this will be a slider that goes from 1 all the way to 12. And we'll connect that to month. Then we need to do the same for days. So that's going to go from 1 to 31. And then the last piece is the hours. So for now, we're going to go from 0 to 23. And there is an option I wanted to stay in increments of 1 hour, but there is an option to dive very deep into the hourly data. So you can go from 0 to 23.999. So you can study increments of the hour. But for the purpose of this study, we're going to just kind of keep it increments of 1 hour. So let's set the date. We're going to set, let's say you want to study June 21st, and the time of day, maybe we want to study noon. So June 21st at noon is the time that we're going to study for our point in time study. And lastly, with the sky type, you can connect a slider that goes from 0 to 5. And the default is set to 0, so it's a sunny sky with sun. And the other options are sunny without the sun, or overcast. Intermediate would be partly cloudy kind of sky, if you want to think of it that way. And then we have cloudy skies and we have uniform skies. For the most part, I'll do a point in time study using sunny with sun to understand the worst case scenario or the best case scenario, depending on what you're using the study for. So that's the sky. Now, there are some optional inputs here, but the most important required input here is the Boolean toggle to run the point in time study. Now that we have the model and sky connected with the day and time that we want to study, we can just go ahead and hit run. I did want to go through what the other inputs are here. So if you're an expert radiance user and you have specific radiance parameters that you want to use, you can connect a text string to the radiance parameters for the settings you'd like to use. Or you can go to Honeybee Radiance. Under recipes, there's a radiance parameter component that you can connect, and you'll just connect that here, and you'll indicate the recipe type. So you have to kind of indicate again here whether or not you're doing a point-in-time grid, point-in-time view, or an annual study by using a slider that goes from 0 to 2. So we're doing a point-in-time grid-based study. If you were doing a view-based study, you can switch that to 1. Detail level, this is where you can choose the accuracy and resolution of your daylighting study. If it's set to low, it will run really fast, but it might not have the same level of accuracy as the high, which will take much longer to run. So the default is 0. I'm just going to leave that, and then additional parameters is additional syntax that, again, for expert level users, you can do it there. So I'm ready to run. I'm going to leave everything default, and then we'll be right back. Set that to true. So my study has finished running. I'm going to go to Rhino and see what it looks like. There's nothing there. Why is there nothing there? So when you run a study, the results don't automatically show up in Grasshopper. We'll have to add some components to our recipe to visualize the results. So let's go to the Honeybee. Actually, we're going to go to the Ladybug tab. And under Extra, there is a spatial heat map component that will drop down. And there's 2 main values that we need to connect here is the results. So we'll connect the results to values. And as you can see, this is a dashed line. This is most likely going to show us an error, but let's connect everything and then dissect the error that we'll see. And then the next input you need is the meshes. So if we go back to where we set up our grid, the output for mesh is right there. So we can take this mesh and connect it to the mesh input here. And as I had indicated, here's our error. And the reason why we're seeing an error is because we have 2 rooms. So if I go back to Rhino, you'll see we have 2 rooms and not all the values are applying correctly. So there's 2 things we need to do here. We need to go back to our Rhino, to our Grasshopper, and we're actually going to flatten the results. So what that requires is to right-click and flatten. So you can see that that dashed line is now solid, and we need to do the same. We need to join our meshes. So because we have 2 meshes here, right, so you can see 2 locally defined values, we're going to use a native mesh join command. So this is a native Grasshopper command component. So we'll pass the mesh through there. And we may have to flatten our mesh as well. No, that's all we needed to do. So let's see. If we go back to Rhino, you'll see that the results are showing up, but you can still see your building. So let's turn off our buildings in Rhino, and that's just our grid right here. And because we're studying June 21st at noon, the sun is at its highest point, and we have skylights in this building. So as you can see, if I go to my top view, my legend goes from 200 lux to nearly 50,000 lux. We want to lower that higher number in order to visualize the impact of our side lighting in addition to our top lighting. So let's go back to perspective view. And there's also a couple of things that we want to do with in regards to visualizing the geometry. So we might want to do a wireframe. Right? So let's go back to Grasshopper. And what we're going to connect to the output for the model is a Honeybee component. Under Visualize, there's a Visualize wireframe. So we can drop that down and connect that. I'm going to move this to the side here so we can watch it in tandem. So this will create an outline of the geometry. So you don't have to have it on in Rhino, and it requires a custom preview if you want to change that color from red to maybe black, and a swatch. So we'll get a color swatch, type in swatch, connect it here, and change it to black. There we go. So now we have an outline, and we can see this. What we're also going to want to do is turn the preview on this mesh off so that we can read the grid clearly. So let's turn the preview off, so now that's much brighter. And we have a video on legend parameters, so I'm not going to go into too much detail, but I'm going to connect a legend parameter from the Ladybug tab here and just change the settings quickly so that we can visualize the values a little bit more clearly. So I'm going to change the max to be around 600 lux. There you go. You can increase that to visualize the change, and maybe it's 2000 lux. You can play around with that and set it up to be what makes the most sense. Yeah, that looks much cleaner. And the other thing I wanted to show in the legend is to add a legend title. In point in time, it's really important that we make sure that the legend reads the values, right? So it's lux, so we can type in here lux and add that in. And the reason that why this is not by default added here is because depending on the type of study that you're doing, it might require different, it could be different values for glare or for percent of the year. So that's all we have for point in time grid-based analysis. Look forward to seeing you in our next video. Thanks for watching.